Hi students, so in this video I'm going to show you how to solve a system of forces which is coplanar, that is all the three forces lie on the same plane and they are non-concurrent, which means they don't meet at the same point. So before we solve a problem like this, I'm going to show you what exactly it looks like in the real world. So imagine you got a yellow plane here and you got three forces acting on it. So that's 2 kilonewton in this direction, 6 kilonewton in this direction, 5 kilonewton in this direction. So what would the net result be of these three forces acting on this plane? So basically we need to find that one force or that one direction that this plane will move along as a result of these three forces. Now that force will have an angle of inclination, okay? So it's going to have an angle of inclination with respect to the horizontal, and it is going to have a position with respect to any point in the plane. Now how do we solve the problem like this? I'm going to show you. So what we do is whenever we have a system of forces, we find the net vertical component of these three forces and the net horizontal component of the forces. So what I have done here is I have assigned a convention that any force going downwards will be negative and left ways will be negative, and the vice versa. My force going upwards, vertical will be sine, and force going sideways will be cos. So I'm going to find the net vertical component right now. So that is going to be equal to first force here, 2 kilonewton. I'm going to write the forces down first. Actually, I'm going to take up some more space. So summation of F vertical will be, I just write the three forces, that's 2, 6 and 5. Now the vertical component, we need to use the sine. That's going to be sine, sine and sine. And now we need to find the angle at which these forces are inclined with respect to the horizontal. So 2 kilonewton with respect to the horizontal will have an angle of 0. That's going to be 0. 6 kilonewton, there you go, that's 25. And 5 kilonewton will have an angle of 90. And now finally we use the sign convention. So since all the forces are now 2 kilonewton is going in this direction, so it's going to be negative. 6 kilonewton this direction, again it's going in this direction, so that's going to be negative. And 5 sine 90, sine is going downwards, negative. Hence my summation of vertical component will be, now I'll have to use the calculator to solve this part. So that's going to be minus 2 sine of 0 close bracket minus 6 sine of 25 close bracket minus 5 sine of 90 close bracket. That's going to be equal to minus 7.535. I'm going to round this up to 2 decimal places, so that's going to be minus 7.54. Now what I have done now is I have also written down my summation of forces for the horizontal. So first of all I write the forces down, so 2, 6 and 5. Then I write cos, so that's cos, 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 because it is all horizontal. And then my angle of inclination, which is the same as above. And finally my sign convention, so 2 kilonewton in this direction, negative, 6 this direction, so the net resultant is again in this way, that's minus, and 5 kilonewton going downwards, so that's a minus. Again entering it in my calculator, minus 2 cos of 0 close bracket minus 6 cos of 25 close bracket minus 5 cos of 90 close bracket, and it is going to be equal to minus 7.437 or minus 7.44. Now always remember the units, so that's kilonewton, so my net resultant will be kilonewton. Now that we have the summation of vertical component and the horizontal component, I'm going to make a rough diagram of what these forces will look like. So when I say vertical, it means going downwards, that's why the arrow is pointing downwards, and because my sign convention is negative, so that's going to be downwards, that's minus 7.54 kilonewton, and sideways again is minus 7.44 kilonewton. So what I have done is resolved all these three forces into basically two forces, one going sideways and one going downwards. Why have I done that? Because now I can find the resultant of these two forces using my trigonometry, and also find the direction again using trigonometry. So let's do that. So first of all, let's see what this is my resultant, that is what it is going to look like. So it's common sense, you got one force is pushing in that, one force pushing downwards, the resultant will be in between, and I need to find this angle theta here. So angle theta will be equal to tan inverse of summation of force vertical divided by summation of force horizontal. And always remember modulus function, that is you only take positive values, so that's going to be equal to tan inverse of (7.54 over 7.44). Now using my calculator, so how do you use tan inverse function? So that's shift key and the tan inverse button here, and that's going to be 7.54 divided by 7.44 close bracket. Always remember, make sure that your calculator is in the degree mode, and hence 45.38 degrees. So my theta will be equal to 45.38 degrees or 45.4 degrees, because you're going to round it up. So now that I have found my theta, I need to find my resultant. So how do you do that? So for that you use a formula. Force resultant is equal to under root of summation FV squared plus summation FH squared. So that's going to be equal to under root of FV is minus 7.54 squared plus under root of minus 7.44 squared. That is going to be equal to, now again I'm going to show you how to do this in the calculator. So my under root sign, open bracket, minus 7.54 close the bracket squared plus open bracket minus 7.44 close bracket squared. So that's going to be equal to 10.592 or 10.59 kilo Newton. Always remember, round it up to 2 decimal places. Now that we know the resultant force, it is somewhat in this direction. That's because it is negative. So my sign convention is negative, positive, positive, negative, and my net resultant was in this direction here because of the quadrant it was lying in. So it's somewhat in this direction. Now I want to know where exactly is its position. So where exactly on this plane does it lie? So what I'm going to do is, to find that out, we are going to find the moment across a given point. So I'm going to draw a diagram first. So I know that my force is in this direction, but I don't know like at what distance and from what point. So what I'm going to do is I'm going to draw my net resultant force here. And I'm going to say this force is at a distance x from my point A. So if I know my value of x, I will have an exact position for my force. So then I'll have a direction that is an angle of inclination, my resultant, the magnitude of the resultant, which I have already calculated to be 10.59, and I will also have the position of this force. So let us now work out how to find the value of x. So for that reason, what we do is we take moments about a given point for a given system of forces. So say I'm going to take my moment about the point A. So what does moment means? Taking moment mean? Okay. So what I'm going to do is I am going to use my figure again. So imagine you got your system of forces which is like this. Now what does moment mean? Moment, taking moment about a point is to see what is the net resultant or what is the net moment about a given point as a result of the different system of forces that you have. So for example, I've got this force of 2 kilonewton going in this direction. What it means is when I tend to pull it in that direction, it causes a movement across this point here. When I try and pull up this point, this force here, 6, nothing is going to happen. That's because this force 6 here passes through the given point A. Same thing with the 5 kilonewton. When I tend to pull it, it will try and pull the entire system downwards, but it will not cause a movement. That means it will not cause, this force here will not cause this system of forces to turn or move across a point. That is my concept of movement. So what I'm going to do is I'm going to find the sum of all movements across point A, and that is going to be equal to, again that's my point A. So now I got here 4 forces in total, 1, 2, 3, and my resultant force 4. So let me consider the first force 2. So I'm going to write the 4 forces down. Actually, I'll take a bit more space. Summation moment about A will be equal to, always write the forces down first. My first force 2, second force is 6, third force is the resultant, which is 10.59, and my fourth force is 5. Okay, now moment is equal to the magnitude of the force times the distance of the force from the given point. So 2 kilonewton, what is the distance of this force from the given point A? So that's my line of action of the force, and it is going to be a perpendicular distance. So it is going to be this distance here, which according to my figure is 53 centimeters, but here we work in the metric system, so we use meters. So that is going to be times 53 centimeters is 0.53 meters. Then you got your 6 times, now because this force acts along the point, that is this force lies on the point A here, so the distance is going to be 0. 10.59 is at a distance of x, which is what we noted in the first place. That's going to be 10.59 times x, and 5 kilonewton, again it lies on the point, so it's going to be times 0. Now sign convention, so 2 going in that direction, so that's going to be negative. 6 goes in this direction, so the net direction is negative. 10.59 times x, so we know it's going in this direction, so that's going to be a negative. And 5 kilonewton goes in the downward direction, that's going to be minus. So what we get here is equal to, calculator, minus 2 times 0.53 minus 6 times 0 is going to be 0, minus 10.59x will be minus 10.59x, and minus 2.53 minus 2 times 0.53 will be equal to minus 1.06. is going to be movement across A. Now if we want to find the equilibrant force, which is basically a force which stops this entire system from moving, it is going to be a force which is going to be exactly opposite the resultant, and that force here is going to be the same as your resultant but in the opposite direction, and it is going to stop this system from moving. If we consider this case, that is, we don't want a system to move, the movement is going to be 0. So what I'm going to do is, in order to find my x, I'm going to say that my movement across this point here, that is the movement force, is 0. So that is why I equate this to 0. It is going to be equal to minus 1.06 minus 10.59x, hence 1.06 equals to minus 10.59x hence my x will be equal to 1.06 divided by 10.59, and there's one more small thing. Now when we wrote this equation down, we considered the resultant force. However, the equilibrant force is in the opposite direction, and hence my sign convention changes. So this negative becomes positive everywhere. That's going to become positive, and hence my x will be equal to 1.06 divided by 10.59 equals to 0.1000, or x will be equal to 0.1 meters. So now for the system of forces, we have the magnitude, which is 10.59, the angle of inclination from the horizontal, which is 45.4, and we have this distance x, which is 0.1 meters or 10 centimeters.